Whether you're sitting perfectly still or walking down the street, you are on an incredible journey. Not just, through your neighborhood, but through space at thousands of miles per hour. Our planet is in this constant, beautiful motion, a kind of cosmic clockwork that sets the rhythm for our days, our years, and even our seasons. So let's break down how this whole thing actually works.
Think about it. It's probably the first thing we ever learn about our world. The sun comes up, it sails across the sky, and then it goes down. It's a pattern so reliable, we've built our entire civilization around it. But what if I told you that that entire experience, everything you see, is basically an illusion?
Yep, it's a grand illusion. The sun is pretty much the stationary heart of our little corner of the universe. We're the ones who are moving, spinning on a planet that's also hurtling through space. Let's dive into the two key movements that create this amazing effect.
All right, first up, let's talk about the most immediate rhythm in all of our lives, that daily cycle of light and dark. This whole experience is all thanks to one simple action, our planet's spin.
This daily cycle is caused by what we call Earth's rotation. Our planet is spinning on an invisible line called an axis, kind of like a giant top. As it turns, the side of the planet facing the sun gets bathed in daylight. And of course, the side facing away is plunged into the darkness of night. This is what creates that continuous 24-hour cycle we call a day.
So why don't we feel like we're spinning? I mean, we're moving incredibly fast.
Well, it's the exact same illusion you get when you look out the window of a moving train. It looks like the trees and the houses are rushing past you, but you feel perfectly still inside the train car. It's because on Earth, we, the atmosphere, everything around us, we're all moving together. So instead of feeling the motion, it just looks like the sun is the one taking a trip across our sky. And here's a really cool little detail for you. A full 360-degree spin of the Earth doesn't actually take 24 hours. Nope. If you measure it against the far-off stars, it's actually about 4 minutes shorter. The 24-hour day we all know and love is what we call a solar day, the time it takes for the sun to get back to the same spot in the sky. And that takes just a little bit longer because, well, we're also moving around the sun at the same time. Wild, right? But our daily spin? That's really only half the story. While we're doing our daily rotation, we're also on a much, much longer journey through the cosmos. A year-long trip, to be exact. This big journey is called revolution. The Earth travels in an elliptical, so kind of an oval-shaped orbit, all the way around the sun. This whole trip takes about 365.25 days. And that extra little quarter of a day, that's a huge deal. It's the whole reason we add a leap day to the calendar every 4 years. It's how we keep our clocks perfectly in sync with the universe. Now, this annual journey brings us to one of the most common, and I mean most common, misunderstandings in all of astronomy: the seasons. Seriously, almost everybody gets this wrong. Let's just put the question out there. We know the Earth's orbit is an oval, which means sometimes we're closer to the sun and sometimes we're farther away. So it just seems logical that summer happens when we're closer and winter when we're farther away, right? Makes sense. Well, here is where reality just flips that logic on its head. The Earth is actually closest to the sun in early January, smack in the middle of winter for everyone in the northern hemisphere. So if getting closer to the fire doesn't make us warmer, what on earth is the real reason for the seasons? It all comes down to this one simple number, 23.5 degrees. That is the tilt of Earth's axis. And that tilt, not our distance from the sun, is the true hero behind our seasons. See, because of this tilt, sunlight strikes our planet at different angles throughout the year. Think about it like a flashlight. When a hemisphere is tilted towards the sun, it gets hit with direct, concentrated rays of light, like a flashlight beam shining straight down on a small spot. All that focused energy creates the intense heat of summer. But when that same hemisphere is tilted away, the sun's rays come in at a shallow angle, spreading that same energy over a much wider area. And that brings on the chill of winter. Let's take June, for example. Around the June solstice, the northern hemisphere is tilted right towards the sun. It's getting that direct, concentrated sunlight, and it's also experiencing longer days, which gives it more time to heat up. That combination is what gives us summer in the north, while the southern hemisphere, which is tilted away, is having its winter. Now, fast forward 6 months to the December solstice, and the whole situation is completely reversed. Now, the northern hemisphere is the one tilted away from the sun. It's getting weaker sunlight and having shorter days. Hello, winter. And meanwhile, the now sun-drenched southern hemisphere is enjoying its summer. So what about spring and autumn? Well, those happen during the equinoxes in March and September. On these 2 days of the year, the Earth's tilt isn't pointed towards or away from the sun. It's perfectly sideways. The sun's most direct rays are shining right on the equator, and just like the name equinox, which means equal night, suggests, day and night are almost exactly equal, all over the entire planet. Okay, so we've got our daily spin and our yearly tilted journey. But when these motions line up in just the right way with the moon's orbit around us, we get something, well, something truly spectacular. This cosmic dance creates eclipses, which are really just a beautiful game of shadows and perfect timing. During a lunar eclipse, the Earth gets right in between the sun and the moon, casting its giant shadow onto the moon's surface. And during a solar eclipse, the tiny moon passes between the sun and Earth, casting its shadow down onto us. It really all just comes down to who's blocking the light. Now, solar eclipses themselves come in a few different flavors. The most dramatic, the most famous, is a total solar eclipse. This is what happens when the moon is in the absolute perfect position to completely block out the sun. And if you are lucky enough to be standing in the darkest part of that shadow, the umbra, day will turn into this incredible, eerie twilight. But sometimes the moon is a little farther away from us in its orbit, which makes it look just a tiny bit smaller in our sky. So when it passes in front of the sun at that distance, it can't quite cover the whole thing. This creates what's called an annular eclipse, leaving this brilliant, fiery ring of fire visible in the sky. And finally, you have the most common type, which is a partial eclipse. This is what happens if you're standing in the lighter outer part of the moon's shadow, which is called the penumbra. From down there, it just looks like a cosmic bite has been taken out of the sun. So when you put it all together, it's this beautiful, intricate system. Earth's rotation gives us our day and night. Its revolution around the sun defines our year. That all-important 23.5-degree axial tilt is the real reason we have seasons. And when the alignment of the sun, earth, and moon is just perfect, we get to witness the incredible shadow play of an eclipse. You know, these movements seem so constant, so eternal,